Good morning, guys. Today I'm going to actually just go over part of the worksheet that you are going to complete. So we're actually going to go over sections A and B together here, and then I would like you to finish by going through C, D, and E. Okay, so you'll have those three sections that you need to do. The first two we'll do together, so I'll just show you what you're supposed to do. So we are going to use the calculator Desmos. So it's an online calculator. Here's the address, www.desmos.com/calculator. So first thing you're going to do is you're going to just look at what function it is asking you to graph. We're going to put these five together on the same graph, and then we're going to state the domain, the range, the y-intercepts, the horizontal asymptote, and f evaluated at x equals 1. So let's go ahead and just put 2 to the x in here. So there's a little keyboard down here in the corner, and we can just put 2. This little a to the b is going to give us the exponent, and we're raising it to the power of x. So this red graph here is the one we're looking at. So this would continue to the left, and this would continue to the right. These would be arrows on the ends. So the domain of this function would go from negative infinity to infinity. The range would go from 0 to infinity. So let's go back to our worksheet and put that on there. So our domain, remember domain is x values, goes side to side, is negative infinity to infinity. The range is 0 to infinity. And the y-intercept, let's see where it crosses the y-axis. That's right here at 0, 1. So the y-intercept is at 0, 1. The horizontal asymptote, remember an asymptote is the point where it kind of comes up to but doesn't touch or cross. So this one would have one at y equals 0, that horizontal line where this is kind of coming up to, but it's never going to touch or cross. So that would be at y equals 0. And then f of 1, that means when x equals 1, what does y equal? So x is 1 here, which lines up with this point here. So when x is 1, y is 2. So f of 1 is equal to 2. Now the purpose of this worksheet is for us to look at the differences and the similarities in these different graphs. So let's go ahead and graph some of these others. We have 3 to the x, 4 to the x, 5 to the x, and 6 to the x. So let's just hurry and put those on there. So we've got 3 to the x. See, it's the same shape, but it's just changed a little bit how quickly it goes up. Maybe we do that one before we go on. So it looks like it has the same domain, it's negative infinity to infinity, the same range, which is 0 to infinity, the same y-intercept, which is 0, 1. The only thing that's really changed here is that the f of 1 is equal to 1, 3 here. So, so this is equal to 3, but everything else was actually exactly the same. Okay. So let's try 4 to the x. So 4 raised to the power of x is the green one. It's just a little more steep again, but same thing. And then notice the f of 1 lines up with 4. We can get right on that point. There we go. So I'm noticing that all of this stuff is the same on all of these, and so I'm just going to do a squiggly line here. These are all the same. These are all the same. On these, they are just f of 1 is just becoming that base number, and that's because when we plug 1 in for x in all of these, we just have 2 to the first power, 3 to the first, 4 to the first. That's why it's 2, 3, 4, 5, and 6. So for f of 1 on these, you can either look at the graph, or you can plug in this x value to this function and just evaluate it. That might be easier on some of them. So the first part says state the similarities of the graphs. The similarities they have the same domain, the same range, the same y-intercept, the same horizontal asymptote. The only thing they have different is that they have f of 1 is different for each one of them. So now on part B, we're going to clear the previous graphs, and now we're going to graph 2 to the x, 2 to the x plus 5, 2 to the x minus 2, and then we're going to see what's similar, what's different, and what happens when we add on the outside, which we probably, since we've done transformations before, already have an idea about that. But let's just go back to our graph and clear all of these. And our first graph is 2 to the x again. Oops, I guess I shouldn't have cleared that one. So 2 to the x power. And of course it has the same things that we had on the top. So the range was negative infinity to infinity. I'm sorry, the domain. The range was 0 to infinity. The y-intercept was at 0, 1. Horizontal asymptote at 0. And f of 1 was equal to 2. So that's just the same as number 1 up here. So then we're going to now graph the same, but we're going to add 5 to it. We're going to see what happens. So 2 raised to the power of x. Notice that my cursor is still up here in the exponent, so I'll have to hit that over arrow to get it back down before I add that plus 5. All right, so now it looks like we have the same exact graph, but it has moved up 5, right? So we have this, the domain is still negative infinity to infinity, but the range now, instead of starting at 0, starts at 5. So it goes from 5 to infinity. So let's write that down over here. So we've got the same domain, negative infinity to infinity. But the range is not 0 to infinity now. Now it's 5 to infinity because everything moved up 5, right? The y-intercept, let's check that, is right here at 0, 6. And if you're having trouble on the graph telling exactly where the y-intercept is, you can always find that by plugging in x equals 0 to the function. So for example here, 2 to the 0 power plus 5. 2 to the 0 power just equals 1. Anything raised to the 0 power is 1. So this is the same as 1 plus 5, which equals 6. So you can either look at the graph to see the y-intercept, or you can plug it in. Either one works. The horizontal asymptote moved up to y equals 5, and then f of 1. Again, I can just plug it in here. 2 to the 1 plus 5 equals 7. So you can plug it in, or you can look at it on the graph. Either one works. Some of the equations may be easier just to plug it in than trying to figure out where it's at, but that's up to you. So next we're going to go ahead and graph 2 to the x minus 2. So we're just basically trying to see how these change when we do different things to them. I'm going to go out of the exponent and subtract 2. Okay, so that red one here. So again, same thing, but now it's just moved down 2. So now the domain is still going to stay the same, right? It's still negative infinity to infinity. The range, though, has changed from negative 2 to infinity. Looks like the y-intercept's at negative 1. So the range went from negative 2 to infinity. The y-intercept was at 0, negative 1. The horizontal asymptote moved down to negative 2. It was at 0. We subtracted 2. It went down to negative 2. F of 1, I can either look at it on the graph or plug it in here. 2 to the 1 power is 2, and 2 minus 2 is 0. So if we go back and look at our graph, yeah, f of 1 is at 0. It's right there. All right, so 2 to the x plus 1, I can just guess now that what's going to happen. That's going to move everything up 1. So my domain, again, will not change. My range is going to go from 1 to infinity. My y-intercept, well, it started at 0, 1 for 2 to the x. Notice how when it went up 5, we added 5 to this. When it went down 2, we subtracted 2. This one's going up 1, we'll subtract 1 from that, so it'll be at 0, 2. Again, we can just put this on the graph and look at it. We don't have to do it this way. 2 to the x plus 1. Okay, so there it is at 0, 2. So get the same thing either way. The horizontal asymptote moved up to 1 because it moved up 1 from 0. And f of 1, if I put 1 in there, is 2 plus 1, which equals 3. All right, so what is similar about all these graphs? I'm going to skip over this last one. They all have the same domain. That's the only thing that's exactly the same. They have different ranges. They have different y-intercepts. They have different horizontal asymptotes, and they have different equivalent. Okay, so what transformation rule occurs when adding on the outside of the function? So if I did plus 5, everything moved up 5. If I did minus 2, everything moved down 2. So it moves up or down with the number added or subtracted. Okay, so that's what you're going to do. You're going to do the same thing we just did here, but you're going to do it in parts C, D, and E. Okay, so do part C, D, E. And that's your homework for today. And you can just turn this in by your email. All right, guys, have a great day.